Neutralization reactions by Raj, Davin, Michael, and Parthav. Introduction. A neutralization reaction is one of the four types of double displacement reactions. So you would assume that a gas or precipitate would form showing that the reaction has occurred. However, this is not the case with a neutralization reaction since it forms water when the reactants are in an aqueous solution. You may ask how neutralization reactions, also known as acid-base reactions, occur. Simply put, when an acid and base react during an acid-base reaction, they form water as a product. During the reaction, the positive hydrogen ions from the acid combine with the negative hydroxide ions from the base to create liquid water, or H2O. This can also be written as HOH to see more clearly how they come together to form water. An acid-base reaction does not always create water. It also creates a compound, given that it is a type of double displacement reaction. Therefore, when the metal cation from the base and the anion from the acid combine, they produce an ionic compound known as a salt. For example, here is hydrochloric acid plus sodium hydroxide. When these compounds react, hydrogen from HCl combines with hydroxide from NOH to form H2O. Sodium also combines with chloride to produce an aqueous solution of sodium chloride, commonly known as table salt. Neutralization reactions work if there is an acid and base present. The reaction between any strong acid and any strong base will form a neutral salt. If there are an equal number of aqueous hydrogen and hydroxide ions, the base and acid will be neutralized, giving a pH value of 7. An exception to this rule is that when a weak acid or base react, it will usually produce a pH that is not 7 because the ions do not completely ionize, making them react with water. These types of reactions are still called neutralization reactions, although the solution after the reaction is not fully neutral.
Current research of neutralization reaction. The main focus will be an experiment on the research on acid rain. The experiment was about why acid rain was occurring in a specific part of India, Kanpur. The researchers did this by looking at data from the past 5 years. In the experiment, it was found out that the water they collected from the monsoon period, when there's no acidic rain, contained 38% alkaline components, while there was 22% ammonium occurring. But in the non-monsoon period, when acid rain did occur, only 4% of ammonium was found. In conclusions, the researchers found out that ammonium played a very big role in neutralizing the acidic water. This research made sense as the ammonium would act as the base to the acidic components in rain, causing the water to neutralize instead of being acidic.
Current usage. Neutralizing acidic lakes. For neutralizing acidic lakes, lime CaCO3 is commonly used due to it being very cost effective, slows the effect of acidification, and the calcium in this compound is beneficial because it supplies calcium to the plants, which is an essential nutrient. This type of lime is commonly called alg lime, that could also be used in gardening to neutralize acidic soil. Alg lime is mainly composed of pulverized limestone or chalk. This is alg lime. Other uncommon methods of liming. Other types of limestone such as CaO and CaOH are not recommended for treating surface water because of their corrosive nature, and it is difficult to control. It still could be used for neutralization because it's very acidic and would require a lot less to neutralize the pool, but these lime could kill fishes at 50 pounds per acre. These two types of lime is commonly used to disinfect pond water from fish parasites and used to sterilize pond prior to stocking fish. This is CaOH2. The other method that can be used is ash, Na2CO3, but it isn't used as much because it is 3 to 5 times more expensive and it doesn't have the calcium in it to benefit aquatic life. And another alternative that is still developing is using cattails. They are believed to neutralize acid and remove metals from the water. These cattails can be planted in lakes for a very low cost since is abundant of them, and is very cost effective in neutralizing acid. Acidic alkaline balance theory. This study or belief shows that imbalanced level of acid alkaline in the body's tissue causes lymphatic congestion, and this impairs the body's ability to move out the waste out of the body. As a result of an experiment, a man neutralized his body's pH to neutral, resulting in 30-pound weight loss, and his health problems are gone. This study shows that the body can only digest mineral and nutrients properly when the pH is balanced, close to 7. To sum up, the study shows that a controlled diet between acidic and alkaline food can improve the body's health. The pH level of your blood or urine is acidic. The treatment is to stay away from acidic foods such as chocolate, peanut, walnut, cheese, milk, because these are very acidic and will add on to acidity level. To neutralize or balance the pH, you can eat vegetables because they are alkaline and will balance out the acidity level. When the blood level is overly alkaline, stay away from lemon, watermelon, lime, grapefruit, mangoes, and papaya. While eating potatoes, white rice, corn, chicken, pecan, cashews are all acidic mildly, so it can level out the alkaline levels. When you drive a car for quite some time, corrosion build up in the terminal and become poor conductor of electricity. This may prevent the car from starting. In this case, it is an acidic battery spill, and to neutralize it, you'll need a base to neutralize it, and using a baking soda or calcium carbonate is a safe choice because it is a weak base. There are more hazardous alternatives such as NaOH, which can corrode skin, burn the retina if it gets in your eye, and the dust from the solid or spray can damage the lungs. Also, it may cause acidic splatters when the sulfuric acid from the battery reacts with NaOH. In an alkaline battery spill, it would be best to use vinegar to neutralize the alkaline or base because it is easy to access and is relatively safe to use compared to other acids.
Future uses. Acid mine drainage, also known as AMD. So the first use of neutralization in the future could be to battle against acid mine drainage, also known as AMD like I said before. Mining facilities, refineries, and smelters produce waste, which contains sulfur within it. When the sulfur comes in contact with air, it oxidizes and is blown away with the wind, releasing acids and toxic metals into surrounding areas for years to come. The toxic metals include zinc, copper, cadmium, chromium, cobalt, nickel, aluminum, and arsenic. This may not be a problem now, but it will be in the near future due to Ontario having 5 smelters, including one right in our city of Mississauga. We can reuse the aluminum from the smelter's waste and form aluminum hydroxide to neutralize the sulfuric acid in the atmosphere, which will prevent further buildup of acid and toxic metals in the surrounding areas. This is an image of what Lake Ontario could look like with the buildup of iron hydroxide. So the next thing we must neutralize in the future is acids that form in refrigerators. Due to global warming, there will be much more humidity in the atmosphere, which causes refrigerants to release acids such as hydrochloric and hydrofluoric acids. These acids quickly corrode metal and interfere with welded connections. This is very dangerous since the metal on your fridges are highly conductive and can give you quite a shock. Sodium hydroxide can neutralize these acids, as shown in the equation below. Finally, a very simple concept, neutralizing acid precipitation with a coating of base upon your house. So most bricks contain calcium carbonate. When in contact with acid rain, the calcium carbonate decays and forms calcium sulfate.
Calcium sulfate is very dangerous, by which it causes your abdomen to swell. To prevent this, a base such as magnesium hydroxide can be applied to your house to fight back against acid rain.
Thanks for watching, guys.